In this video, I would like to show you a few examples of using C++ standard library algorithms in real code, and I would like to reopen the project that we tried to work on earlier. Just going to open a string. Remember Java-like string that we built earlier in our course? And the string has a source, so there's a main file that creates a Java-like string. Remember, we tried to experiment with different Java-like methods implemented as C++ functions in this program. And also, of course, we have the header file that contains the definition of this string. So it's short of all of the methods, but today perhaps we could try these three. Okay, so we could try, for instance, these three new methods like this. And basically, Java supports conversion of the string to lowercase, conversion of the string to an uppercase, and also we could use a function that removes the heading and trailing spaces from the string. So if there's any kind of white space in that present in the string, we can remove it. So these new three functions could be benefiting from some of the standard library algorithms that we discussed today. So this is what I'd like to try. However, before we finish this work, I'd like to also point out that we're not completely done with the string design in terms of correctness of its implementation. You can review some of the intricate details about the design rules that we placed here, and we were in need of a copy constructor because we needed to create a deep copy of a string object in case if it was using dynamic memory allocation. Now, if I go over here and try to do something like this, for instance, string hello, which already exists in memory, and if I call functions such as hello concatenated with something else, in fact, let's concatenate it with something like just a series of spaces so that we can prepare to work with the new functions such as trim, so that if we can populate our string with some additional spaces right here, we can use later we can start using trim to get rid of these spaces. So what I'm trying to do is that whatever the content of the current version of the hello string is, I would like to invoke concatenation function, which can be found right here, which returns back a temporary string which dynamically allocates the string combine of this string and the string that we want to provide as an argument. And let's build this program. Right, so we haven't really added much of the new code except this this attempt to modify the string based on the results of concatenation. So if I run this in debug mode, if I say start debugging and run this in debug mode, we're actually experiencing a problem. The program throws an exception. If I take a look at this call stack, you can see that this is happening exactly on pretty much on this line. So remember, the debugger is showing this curly arrow that tells us that basically something just happened, exception was thrown during this execution. And if we were to return nicely from here, which we didn't, the return statement would be executed next. But for now, we're stuck somewhere in the depth of these function calls, and somewhere we just happen to experience a significant problem, significant enough to say that apparently delete operator decided that there was some kind of memory corruption. So this is corrupted memory. So what is happening here? Let's examine this very quickly, and I will now stop my debugging session and explain what we have and what we need to change before more or less completing this string class and making it behaving much closer to Java-like string. So earlier we discussed that our implementation of concatenation function returns back a copy of the string that uses dynamically allocated block of memory, and it populates this dynamically allocated block of memory with some spaces right here. Right, so that it places some spaces, but at the beginning of the block it copies the content of the original string. Right, so if this hello contains this, we add this chunk of spaces right here. So the hello world is basically copied into this part of the new string. But the important thing is that this entire function concatenate, when it returns back a temporary object, a string that looks like this. And then we assign it to hello, and hello basically just copies everything into its own implementation. So now hello becomes this, which is nice, and that's exactly what we need, because that's what the default assignment operator does. However, this temporary string allocated this block of memory dynamically, and therefore hello now became an owner of dynamically allocated memory. But then the temporary object produced by concatenate is destroyed. So this essentially this memory will be destroyed by temporary object returned by concatenate. And now hello is now pointing to memory which is no longer allocated. And then when hello goes out of scope, okay, we begin to realize that it's the same situation as with copy constructors. So we said that in case of copy constructors, we needed to create a deep copy of an object. In case of an assignment, we must do the same thing. In fact, it's very often the case that when you have a need to add a copy constructor, you also need to overload an assignment operator. So let's start with an assignment operator, and this will be the signature of our assignment operator, and we would like our string to control the assignment of one string to another, as opposed to use compiler automatically generated code which simply copies everything bit by bit, and therefore again it's a situation with a shallow copy. So at the very bottom of the class string declaration, I will copy and paste the fact that there could be some other overloaded operators, but right now I'd like to overload an operator equals. This is the assignment operator has to be a member function. So it's a requirement of C++ standard. You cannot define it outside. It cannot be a binary operator. It's just an function like this, with an output operator. It's a member operator, and so it just like constructor, very similar to the constructor, it takes a reference to another object. So this would be another object returned by concatenation. So this would be another object, and of course this string is hello. I'm sorry, this hello variable, and we're going to be using our own custom version of this assignment. So how can we implement this assignment? Let's take a look.